Welcome back to Quest Edu Physics students. This class is about the refraction students and mostly useful for the students who are preparing for the competitive exams and those who are interested in foundation in physics. Okay, students. In this class, we talk about the refraction of the light, particularly about the Snell's law and its applications. First of all, we have to understand what is the refraction, students. In simple words, you learn that it is a bending of the light ray when it is traveling from one medium to another medium. If we go into detail, we can define it in different ways, students. It is a change in speed of the light when it is traveling from one medium to another medium. Means what? When light is propagating from through a pair of media, in which one is the rarer and second could be the denser, students. The phenomenon of this refraction need a pair of medium, students. Not like in reflection, you learn that it only required a single medium to exhibit the phenomenon of the, what is that, reflection. Here, refraction need a pair of medium, the two optical medium. Just draw a diagram which explains us how it is. Say, it is the boundary of separation between two different medium, and we are calling it as A and is the B, and we are dropping a normal. It is a normal which is drawn over this boundary of separation. Say it is the rarer and it is the denser. They are optically rarer and denser medium, students. Let's make a light ray to fall on. It is a light ray which is coming from a distant source and it incident on the boundary of the two medium, students. It is the rarer and it is the denser. Here, if it is not obstructed by this medium, that means what? It is denser when compared to the rarer. It has to travel in this way. Light travels along the straight line. But because of the change in density, the path of the light ray being changed. That means it travels in this way. Here, if you take this one, you say it is a point of incidence A and OA is the incident ray. Then we can say OB is the refracted ray. Here it is the angle of incidence and it is the angle of refraction. And it is the deviation produced by the light ray. Angle of deviation. If you watch it clearly, you will find that when light ray is passing from rarer to denser medium, it bends towards the normal. Here, the arrowhead showing the same thing. It bends towards the normal. Then, angle I is greater than angle R. And similarly, angle of deviation is the difference of angle of incidence and angle of refraction. You have to remember that when light is passing from rarer to denser medium, the refracted ray bends towards the normal. Okay, students, the same thing could happen when light is propagating from denser to rarer. It is a normal, usually I draw as a normal, you say N as the boundary of separation AB, and say it is the denser. See the difference, students. In first case, I took the first medium as the rarer. Here denser and second medium is rarer. Both are optical medium, students. Optical means what? You can see through. And we are making the same. We made a light ray to fall on. See this, the light ray. Okay, it is a point of incidence and we call it as the OA. It is the actual path of the light ray, students. Students, then because of the change in density, it is the denser and it is the rarer. This ray moves away from the normal like this. Okay, students. You watch it, it is the angle of refraction and it is the angle of incidence. Okay, students. Here in this one, angle R is greater than angle I, and angle of deviation is the difference between angle of refraction and angle of incidence. What you have to remember here, when light is passing from rarer to denser medium, the refracted ray bends towards the normal. And see here, when it is traveling from denser to rarer, it will move away from the normal. Means what? Here in this one, the speed being increased, it is the speed decreased. Here, in rarer medium, it has more speed, and in denser, it has less speed, students. Now, students, we are going to talk about the laws of refraction, students. What are the laws of refraction? The first law can be stated like this, students. The incident ray, the refracted ray, and the normal drawn to the surface lies in the same plane. That's the first law. First law tells us that, what is the statement? The incident ray, the refracted ray, and the normal drawn to the surface lies in same plane is the first law, students. First law of refraction it is. Wait, what it is telling us, here if you take a pair of medium, say it is A and B, and we are dropping a normal here, okay, normal drawn in that way. Okay, we are making a light ray to fall on. It is the incident ray, students. Say it is the O, so A, say it is the rarer, and it is denser. Okay, you know that the actual path of the light ray is this. Because of the change in densities. Okay, students, what did happen here? It changes its path and moved in this way. It is the angle of incidence and it is the angle of refraction. If you apply the same thing, the first law, what is that? The incident ray, this is the incident ray, OA is the incident ray. The refracted ray, OB, is the refracted ray here. And the normal, it is, and lies on same plane, or lies in same plane. It is the first law. Okay, students, telling us that the incident ray, the refracted ray, and the normal drawn to the surface lies on same plane is the first law. Then we go with the second law, students. What is the statement of second law? It tells us that, it is the important, students, for a given pair of medium, for a given pair of medium, the sine of the angle of incidence to the sine of angle of refraction remains constant. It's the second law, student. Second law tells us that for a given pair of medium, see this, is a pair of medium. It's the first medium, it is a rarer, and it is the second medium, it is optically denser. It's telling us that for a given pair of medium, the ratio of the sine of the angle incidence. Here, the ratio of the sine of the angle of incidence. What is the angle of incidence? I. He said that sine I, okay, to the sine of the angle of refraction. Refraction angle is R. Sine R always remains constant, is said. Okay, students. This constant is known as the refractive index, students. Then this equation can further written as sin I by sin R is equal to mu. You have to read it as the mu. Mu is what? Quotient of refraction, students. Or you can say it is the refractive index, where mu is refractive index. Okay, students, here we are keeping the notation and you have to read it as refractive index of the second medium with respect to 1. Then it can be written as mu 2 by mu 1. Then this can also be written as mu 2 by mu 1 is equal to sin I by sin R. Or you can write it as mu 1 sin I is equal to mu 2 sin R. Okay, students. This second law is known as the Snell's law, students. The other name of this law is Snell's law. According to the Snell's law, the ratio of the sine of the angle of incidence to the sine of the angle of refraction always remains constant. Here, from this one, we wrote it as mu 1 sin I is equal to mu 2 sin R. Okay, students. The second law. Students, let's talk about the applications of the Snell's law. What I told, according to the Snell's law, the ratio of the sine of the angle of incidence to the sine of the angle of refraction always remains constant. Then, according to Snell's law, you can write mu 2 upon mu 1 is equal to sin I by sin R. Here in this one, mu 2 is the refractive index of second medium, students. You have to remember these things. Refractive index of second medium, and mu 1 is the refractive index of first medium. Okay, students. Mu 2 is the refractive index of the second medium and mu 1 is the refractive index of first medium. Now we are going to learn about the critical angle, students. It is the major application of Snell's law. It is a critical angle. Generally, we show this critical angle with the letter C. First of all, we have to understand what is the critical angle is. Critical angle, the definition of the critical angle goes like this, students. It is a particular angle of incidence, for which the angle of refraction is 90 degree. It's the definition of the critical angle, students. It is the definition of critical angle. What is the critical angle? It is a particular angle of incidence for which the angle of refraction is 90 degree. The condition is, what is the condition here? Light ray has to pass from denser to rarer medium, students. Denser to rarer medium. It is the condition. This one you have to remember. It is the particular angle of incidence for which the angle of refraction is 90 degree. And the condition is what? Light ray has to pass from denser to rarer medium. Then see how you will understand this. Take a set of media, students. Is the AB boundary of separation. Say it is the rarer. I consider it as the air. Air has the less refractive index, students. And I am taking it as the water. Water is denser when compared to the air, students. Okay, it is the denser medium. And C, students, is the first medium. And it has the refractive index of mu1. And the second medium, which has the refractive index of mu2. Okay, students. It's a denser medium, which has the refractive index of mu1. And it is the rarer medium, which has a refractive index of mu2. I'm dropping a normal here. I said earlier in the statement, if you see the definition of that, it tells us that the light has to pass from denser to rarer medium. Say, this is the source of the light, one ray. Okay, students. Here, the light ray incident at a particular angle. Then for that angle, what did happen? Actually, we learned that it has to enter into the second medium. Say it is the angle of incidence I, and it gets refracted, and it is the angle of refraction. Say it is the I1 and it is R1. Okay, it's the first case, students. In first case, we had the I and as well as the R. Now, what I am doing, I am further increasing the angle of incidence. I increase the angle of incidence to I2. Dramatically, what could happen? Instead of entering into the second medium, the light ray just grazes the boundary of separation. Okay, here we got the angle of refraction R2, that is equal to 90 degree. Then this angle of incidence I2 is said as the critical angle. Listen to me, students. When we make the light ray to incident at an angle of I1, then what happens? We saw the light ray enters into the second medium, making an angle of refraction of R1. Then after we further increases the angle of incidence, dramatically what did happen? The refracted ray grazes the boundary of separation. Means what? This angle, okay, is 90 degree. That's why we got the angle R2 as 90. Then apply the same to the Snell's law. As you learn that mu2 by mu1 is equal to sin I by sin R. Okay, students. What is the mu2? Mu2 is the rarer medium. That is, we said air. Air has a refractive index of 1, students. Then I am substituting a value. I am calling it as the mu. The first. Mu2 is equal to 1 by mu is equal to sine of the angle of incidence. Here we have to take. It is sine C by angle of refraction, sine 90 degree. As you know that sine 90 degree is equal to 1, and we are substituting the values here. 1 by mu is equal to sine C by 1, or mu is equal to 1 by sine C. You can further write this one. Okay, in the same way you can write C is equal to sine inverse 1 by mu. Okay, students, critical angle can be had as C is equal to sine inverse 1 by mu. What is the critical angle here? It is a particular angle of incidence for which the angle of refraction is 90 degree, and the condition is light has to travel from denser to rarer medium. You can define it another way also, students. It is a particular angle of incidence for which the refracted ray just grazes the boundary of separation. See this ray is grazing the boundary of separation. And the condition is same, light has to pass from denser to rarer medium, students. Okay, that's why we took second medium, and it's the ratio of second to first medium and sin R, and we took it as the mu2 is the second medium, which has a refractive index of 1, and is the first medium, which is water or any denser medium. Okay, mu1 is equal to mu. Then we got the relation C is equal to sine inverse 1 by mu. Let's do one problem which depends upon these concepts, students. Okay, he's asking us find the critical angle at water-air interface. He's asking us find the critical angle at water-air interface. Here, water has the refractive index. It is the water. It has a refractive index of 4 by 3, students. Okay, students. And air, you know that, 1. And we are using the Snell's law. What is the Snell's law? Okay, mu2 by mu1 is equal to sin I by sin R. Okay, students, so mu2 is the second medium, has a refractive index of 1, and water, it is the first medium, has a refractive index of 4 by 3, and sin I is taken as the C, and sin 90 here. It is 3 by 4 is equal to sin C. As you know that sin 90 is equal to 1, and sin C is equal to 3 by 4, and C is equal to sin inverse 3 by 4. Okay, students, it is sin inverse 0.75. It is the critical angle at water and air interface. You can take the same example for what's that, glass and water interface. Let's do one problem, students. The problem is like this. Find the critical angle at glass and water interface. Okay, how we have to do this problem? Okay, first we have to know what is the refractive index of the glass. Glass is 3 by 2, students, and water, as you know that, it is 4 by 3. Okay, we have to use the Snell's law here. According to the Snell's law, mu2 by mu1 is equal to sin I by sin R. Okay, we learn that. I depict the diagram. See what happening. It is the first medium, it is glass, and the second medium, it is water. Okay, and the ray grazes the boundary of separation. R is equal to 90 degree, and C is equal to I is C. Then we are applying the same. First, put the values of refractive indexes of first and second medium. Mu2 is what he said? Water, rarer medium it is. Glass, denser. Okay, student, mu2 is water. Water has the refractive index of 4 by 3. Okay, and the first medium is glass itself. It is 3 by 2. And I is replaced with the C, and R is 90 degree it is. Then we can write it as a sin 90. Then you can write further it as 8 by 9 is equal to sin C, since sin 90 is equal to 1. That is sin C is equal to 8 by 9, and C is equal to sin inverse 8 by 9. Okay, you can find out the value of the, what is the sin inverse 8 by 9 in your clock table, students.